Should go ahead. Okay.
Okay, great. Well, hi, everyone. My name is Donnie Shaffer, and I am Vice President of Professional Services and Customer Success here at RiverMeadow. I have 20 years of experience developing and delivering transformational solutions for Fortune 500 clients across a wide range of industries. And at RiverMeadow, I'm responsible for post-sales activities, and I help enable our customers through their cloud journey. And I'd also like to introduce my co-presenter for today's session, Movair CTO Andy Slivinschi. With over 17 years of experience in software and IT consulting with a focus on delivering business value, Andy is responsible for helping transform Movair into an enterprise SaaS company that it is today. And lastly, I just want to take a quick minute to thank Microsoft for hosting today's webinar, and for Andy and the entire Movair team for helping put it on and their continued partnership. So next slide, please. So before I hand it over to Andy to talk about solutions, I want to open up and take a minute to talk about a few challenges around cloud migrations, since most enterprises are contemplating or already migrating to the cloud and are having to deal with a sense of overwhelming complexity and risk. Now, there are a lot of different levels of challenges that customers face, but when we take a closer look, most are really not directly related to the cloud itself. Most of the challenges are really not about the customer's target environment that they're going to operate in. So for example, it's not the core services are not suitable, or that it does not provide the security and performance or those type of things. Most challenges we see customers run into are really around the following areas. The first challenge we tend to see customers experience is how to select, prioritize, and categorize the correct workloads they want to migrate to the cloud. And the second we tend to see is around execution. And that is, are we making it too complicated? Or are we using the right tools and platforms like RiverMeadow and Movair to help automate that process to make our move to the cloud easier? We see this every day with our customers, regardless of where they are on their cloud journey. Those that are early in their journey wonder, where do I start? How best to proceed? And those in the middle of their journey tend to still struggle getting through their discovery and assessment phase, which tends to significantly result in project delays and cost overruns. So that's what we're here today to talk about in this joint session with RiverMeadow and Movair. Next, please. So let's talk about this at a very high level. So at this point of the cloud journey, we see this as the logical path. Movair is a discovery solution that provides intelligent data and insights and dependency mapping, which is needed to plan your cloud migration, and it continuously can optimize, monitor, and analyze your environments. Movair can scan environments at a rate of up to 1,000 servers per hour in multiple instances in less than 1 day. And all this data is really crucial because it helps drive business decisions around cloud once you have your applications selected and prioritized and that are a good fit for your cloud environment. And then RiverMeadow, we really help with the validation with our rules-based engine and execution of the migration strategy, and we do it at scale. We'll learn more about migration execution during our third episode of the cloud journey. So let's start talking about how to go about solving for these challenges when discovering and assessing your environment. So at this point, I'm going to hand it over to Andy, who will take us through the depth and breadth of these processes.
Thank you. I'd like to start on the next slide with just a visual representation of where we are in this cycle. So we're talking about discovery and assessment, which is step 2. After we have this vision that we will get to the cloud, we will get to a better place. We will go through this exercise to achieve a benefit that we don't have today, whether that's cost optimization, licensing optimization, whether that's just getting rid of an old data center. Everybody has a vision about where they want to take their company. We fit into that vision with a very simple proposition: get the right data, get the right ingredients, which typically is data, inventory, performance, and cloud sizing. and you will have a good chunk of that work already done, because what people don't want to have is a surprise. It's actually, we have a saying, don't leave data behind, because in the end, it will come back and haunt you. Whether that's a user, whether that's a workload, whether that's an application, they're all very important bits. Otherwise, they wouldn't be in your ecosystem today. If you tend to ignore them, or to say 80% is enough, or don't worry, we'll just leverage those old spreadsheets that we've been having for quite some time, because they're probably good enough. That is what we're trying to help customers avoid. So what are these key ingredients that we're talking about? I'll mention them briefly. Starting with the next slide. Inventory is step one. Doing an inventory assessment is not something that should be cumbersome, time-consuming, or burdensome on your staff. That's what we're preaching. We've been a consulting firm, going in and spending time with customers on site. And one thing I remember from those days is that every time you ask for something, that is a minute, an hour, a day you take from somebody's time that they could be actually doing and solving a real problem. Collecting data should not be something that people dread. We take that to heart, and we've automated as much as we can from both the platform perspective. So we deal with Windows and Linux on equal footing. All types of devices are welcomed, whether they're physical, virtual, or in between, meaning in the middle of a cloud migration, we can detect those. We pull data from the working set, which is really important. We'll talk more about that when we get to performance, but that's also important when you talk about inventory, because leveraging somebody else's API may be good or fast, but it's also risky, because you are relying on somebody else's decision about exposing the data that they thought it's important, versus relying on the data that may be actually important to you and your use case. Looking at applications, software, putting devices on a map. Again, remember, leaving no user behind is one of our core principles, or no app behind, or no device behind. Also matters when you talk about geo-dispersed companies that could have multiple locations and multiple offices around the world. Looking at AD from a different angle. AD is still a very good ingredient for discovery, because it contains a holistic view, not only from a device, but also from a user perspective. And also latching onto any architectural decisions that are innate to that system. So things like, what preferred platform a company has deployed on, both from a hardware and software perspective. Is really important when we talk about discovery. But doing all this in an automated fashion, meaning single-click deployment, very small binaries that self-dissolve at the end of a scan, and also all the data that's being collected is fully encrypted on its way to the processing engine. It's something that we take very good care of. On the next slide, we will talk about performance data. So the second ingredient, obviously knowing where your assets are is one thing, but actually knowing how hard they are working or how little they are doing is equally important. So we call that performance data, or ARC, standing for actual resource consumption. You'll hear us use that term a lot, because it is something that we've coined. And the reason we're doing a little bit different is CPU and RAM, pretty de facto standards, but storage, IOPS, and throughput, we tend to see that about 90% of devices that get sized for the cloud up. So meaning, instead of 2 cores and 4 gigs of RAM, our recommendation in the cloud is, let's say, a size up that has more cores, more RAM. It's actually not necessarily driven by the CPU and RAM consumption, but it's actually driven by the IOPS and throughput, which are hidden, right? They're not obvious. People don't go quickly and say, oh, my device has 1,000 IOPS utilization. Everybody says my device has 2 and 4. IOPS is something that is a little bit more delicate to measure, and it is very, very dependent on the hardware that the machine is running on, whether it's physical or virtual. And we do both. And the other thing that's really, really key when we talk about cloud sizing is what else is talking to this machine. It's not necessarily just how hard it's working, but who are the dependents or what are the relationships between this machine and others. And that's what we call app dependency mapping. We do this both at the device and a database level. And then to kind of link it all up, we look at ways to optimize anything we can on that machine. So when we recommend a machine for the cloud, we don't just say 4 gigs of RAM and 2 cores and 1,000 IOPS. We actually look at opportunities to save on the customer. CPU optimization for things like SQL is key. Most customers tend to actually move to the cloud and get more bang for their buck, meaning more performance, because a cloud vendor will typically give you a newer CPU model, better architecture, but also actually saving on licensing. So leveraging less cores once you move to the cloud for things like SQL Server is very important. And last but not least, on the next slide is cloud sizing and cost. So modeling, very important. Looking at different regions, looking at how machines are priced in those regions. A little known fact that not all sizes are available in every region. So when we do a recommendation, remember geotagging is one of the ingredients for data plus performance, and then deciding on the right data center where you put those devices is key. So doing that in real time without actually going back and recalculating anything outside of a click of a button is key. To sum it all up, where do you start, right? What is the target? What application on one server, one user you start with? That's what we focus a lot on with the data that we collect. So finding the best target, the best location, the best data center, and the best size, both from a VM and a storage perspective, is what we reveal with the data that we collect.
Hey, Andy, this is Donnie. So I have a question on the performance data. What is your recommendation when a customer might in a given time period, say a month, has critical periods, maybe it's end of month reports or something of that nature. What is the recommendation of how you collect all that performance data? Is there a recommended time frame of how long they need to run the discovery in the environment, for example?
Great question. Yeah, absolutely. We recommend a minimum, and it depends on the customer, but a minimum of 7 days is very useful. When we calculate performance based recommendations, so sizings, we do them with a certain degree of confidence. And obviously there's 2 ingredients there. One is your sample size, so your population of intervals that we collect data over. So a day for somebody that has a very static use may be enough. 7 days is good. 30 days is great. And the reason I say 30 days is, as you kind of alluded to, month-end processing still happens. It's still something that people do. Longer the times where you can say, I'm gonna just do everything in batch. The reality is, depending on the system and the workload and the usage, to capture that month end and sometimes even quarter end is very important. We can collect data for as long as you can run that arc scan. We average it, and the trick of the fact is that we use a standard deviation. So we use a very known method to smooth out any spikes, but also to get enough confidence that the size that we recommend, and the percentage of CPU, RAM, IOPS, throughput, all those ingredients have been dealt a high degree of confidence. So we do both recommendations with 2 and 3 standard deviations, and they're available, meaning the user can actually pick those and say, well, I am more susceptible to spikes, therefore I'm going to choose 3 standard deviations. Or I'm not. My machines kind of run, steady go lucky, and then I'm good enough with 2 standard deviations. So both options are available. But to answer your question, 30 days is where we normally tell customers to go for. But as I said, anywhere from 1 to 90 is possible.
Great, thanks, Andy. And you mentioned the word bots in that statement there, and I'm wondering, is there anything that a user has to install in the environment, or is this agentless?
Absolutely not. So the only prerequisite is a network connection between one device and our APIs. That's typically achieved very, very simply on a machine that the customer dedicates. Our console, what we call, is deployed as a single binary that requires no installation, a simple double click and it will run. From that console, the bots are deployed, but we do support 3 types of deployment. So one of them is a service run deployment. The advantage with that is it survives a reboot, right? So when you're talking about collecting data over, say 30 days, most likely a server will be restarted in 30 days just for security updates or patching. It's normal for a server to go offline for a few moments in a 30-day period. Installing our bots as a service, which can be fully customized in the console, is the preferred method, and that's what most of our customers go with. If the customer does not want services run, then we can run them as a simple executable. So they will run as an exe or as a binary on Linux, but they will not survive a reboot. So if the customer chooses, again, that's option 2, they can run, and again, it's at the lack of the scheduling for that server to be restarted. But we will collect that ARC data up until that point where that machine was rebooted, no problem with option 2. Option 3 is a pure remote scan, and that is also available. The caveat there is that the performance data that we collect is very minimal, right? So we'll just collect some basic stats about the machine. So there are 3 options. They're both considered agentless because at the end of the inventory and ARC bot scan, we leave nothing behind. So the bots themselves will dissolve. They will clean up after themselves, and the machine will be left in the same state that we found it.
Great, thanks for explaining that. So I think we have a case study slide on the next here. Can you just quickly take us through this case study, and then we'll open it up for Q&A?
Yeah, absolutely. This is a really good case study because it highlights 3 things. One, a very known customer with fairly good controls and a large footprint, right? So your, say, Anheuser-Busch InBev hosted very large number of very distributed environment, large number of servers and distributed environment. Existing SAM tool in place, SCCM, a very good product that focuses actually not on discovery or performance data. It focuses on configuration management. That's what SCCM is known for. What Mover does, and it does really good, is detect such a tool that's already in place. And what we will do is leverage that data to support our discovery, right? So if we find a CCM installed, we will supplement any machines that don't have complete inventory data. Remember, inventory is what SCCM collects. And anything else that we don't have visibility, we can launch our bots on those machines. So instead of targeting every single machine in the environment, we can leverage SCCM and then supplement the data. And what we found within Anheuser-Busch is that over 25% of the estate was actually not visible to SCCM. So that's kind of the first thing we highlighted there, right? SCCM was great, but the coverage, a metric that we hold very dear, was not 100%. SCCM actually does a report of coverage. It just says, I found so many devices and I deployed agents on them. We plugged that gap. We plugged that 25%. Why is that important? we go back to the cloud sizing and app dependency mapping. You don't want to leave anything behind. You know, when you move an app to the cloud, if you left, you know, one server or one user behind, they're the first one that are going to complain. They're the first one that is going to say my thing is not working anymore, and that project can become overnight a failure instead of a success. So that 25% is typically where things are left behind, and that's what we've covered. The second thing is that we found over 70% underutilization for their assets, which means an asset that's provisioned is running, but 70% of those resources are not utilized. So if you would do that basic sizing of 2 procs, 4 gigs of RAM, let's move it to the same 2 procs and 4 gigs of RAM in the cloud. That means I'm actually leaving behind more than 1 proc and 3 gigs of RAM. That is a lot of resources that in the cloud you're actually paying by the minute, right? So leaving those on the table is really kind of, you know, throwing 70% of your budget out the window and getting nothing in return. So that's kind of really important to know that, you know, when you are running something on-prem, you've bought those resources, you've actually paid for them. When you go into the cloud, you're going into a totally different model, and actually sizing the right thing is very important.
Right.
And then lastly, sorry, the last thing I wanted to bring up there is doing this in real time. So actually allowing the customer to see their environment change over time is the key part here, right? Not taking just a simple snapshot, right? Which is what SCCM is really good at, but showing them kind of how the environment changes and where those machines have been versus where they're going was key to make this a success.
Okay, great. Thanks for reviewing that case study with us, Andy. So I think that takes us to the Q&A, and I'm not sure how much time we have allotted still, but that's the end of our presentation.
Yeah, thank you for that. We have about 3 or 4 minutes left for any remaining questions. I did look at the Microsoft Partner Community online post about this event. I don't see any new questions or comments from any updates from last week. So want to invite anyone on the call to either come off of mute and ask a question or to drop your question in the chat and we can read it from there.
This is Donnie. I'll just ask Andy a quick question. Andy, are there some of the more difficult apps? What are some of the more difficult apps or that you guys analyze?
Well, I'll go like for probably an easy one, but something that I'm sure everybody that's listening to this call is running, and that's SQL Server. And it's not that the difficulty is probably not that SQL is a very prevalent and fairly ubiquitous product, but the dependencies on it are very large. And what I mean by that is, you know, if you have an application running on top of SQL, the key part there is to realize not just that there's a connection, that there's a user, that there's a life cycle to that connection, but to also realize what happens after that connection is gone, after that disconnect, right? The fact that SQL actually does a lot of work in the background, that SQL runs a lot of processes to, you know, rebuild indexes, to recreate, tables, to actually propagate data behind the scenes. And those are the things that consume things. Those are things that consume CPU and cycles and IOPS and throughput that are normally not obvious when you just look at a server. The other thing that's really important to realize is SQL is not just a database provider. It actually has a lot of, let's call them secondary features, analytics, reporting. There's clustering options within SQL. All those, let's call them minor features of SQL actually play a big part in why SQL became such a popular product. So detecting those without going back and saying, yep, I found a list of, 100 SQL servers. Let's go and convert all those to SQL, instances or, SQL Azure or PaaS instances. That might be one way to do it. but actually looking at those servers and seeing how they're being used and what of these secondary features are turned on and who are the primary and secondary and tertiary users or applications that connect to that SQL box is very, very important. So I kind of picked the easy one, but it's really probably the most complex and deep entrenched product that I would say we've moved to SQL we've moved SQL into the cloud ourselves. We've tried all of them, and there's pluses and minuses to all. So coming from SQL running on VMs, SQL running in Azure, SQL running on Linux, which is also something that we run. They all have their pluses and minuses, and knowing which option is right for you, the customer, is key to make that SQL migration a success.
Okay, great. Thanks, Andy. Well, I think we've run out of time, and I just want to thank Keisha and Microsoft for hosting this today, and just want to throw in a quick tag here for episode 3, which is scheduled for next week on Tuesday, April 16th from 9 a.m. to 9:30 Pacific time. And that topic will be around how to make your cloud journey executing a successful migration project.
Excellent. Thank you both for this presentation. Thanks for everyone who was able to join. Andre, you can go ahead and conclude the recording. We will have this posted on Microsoft Partner Community with episode 1 as well by the end of business today. Thank you, everyone, and hopefully you're able to join us next week for episode 3.
Thank you.
Thank you.
All right, take care, everyone.
Awesome. Thanks, guys.